Weather dudes and dudettes, welcome to another episode of State of the Weather Address, September 24th, 2016 edition. And what I'm going to talk about right now is something that may be brewing in the Atlantic Ocean right now. So we're going to talk about what could be happening around October 6th through 8th if the models are sane, okay, in predicting this. I'm also going to briefly go over what the next week could bring across the United States. And I'm also going to show you a mini tutorial, a little bonus tutorial. And we're going to talk about model ensembles, okay? And there's a method I developed called the Model MUI Checkpoint. And we will go over that towards the end of the video, so stay tuned for that. Now, a little disclaimer. This is for weather enthusiasts, okay, people who like weather. This is probably not for someone who is going to take this forecast and run with it. A lot of this stuff can change, especially long-range stuff. So this is just for entertainment purposes only. This is just kind of my thoughts and kind of what the models are showing. This is just kind of a fun discussion, and I'm going to show you some forecasting techniques, and we're going to make it simple, easy to understand. And yeah, so let's crack right into it. All right, so what I thought I'd do first is crack right into the National Hurricane Center's page. And this shows all our tropical systems going on right now. We've got Carl out here, and he's been kind of dancing around out here for days. And that's going to continue to dance around. That's a tropical storm. We got Lisa out here kind of sputtering on and off. But this is the thing to watch right here, just off the coast of Africa. We've got a little tropical disturbance here, a little wave kind of sputtering on and off. But that's expected to track towards the United States. Now let's see what they're thinking. They actually have this thing moving out towards this area right here, maybe the Caribbean, whatever. And then what the models are actually doing is it's actually, the latest models are now tracking it into the Gulf. And I'll get into that in a second, but it's something definitely to watch right now. We're towards the peak of hurricane season, so why not? And so let's find that on satellite here. This is Carl out here. This is Lisa right here. And this is the wave we're watching. You can kind of see it starting to sputter off the African coast right there. Now let's zoom in. And there it is right there. Kind of sputtering on and off. And this is the area to be watching right now. And the models have this coming in to the United States around October 6th through 8th. Now I'm going to show you how that evolves here in a second. But first, let's go over how the next week could occur. Alrighty, so this is the precipitable water overlaid with surface winds and surface pressure. And this is for currently right now, Saturday, September 24th. And what I thought I'd do is I'd plot out all the lows and highs and the big features. And we're going to watch how they evolve throughout the week. So you'll get a little bit of a forecast over the next week, and we're going to see how that interacts with the hurricane system or tropical storm or whatever the heck it is that comes on shore by this model. So right now we got a low pressure system as of Saturday, September 24th, a nice cold front moving through, plenty of moisture, probably got some nice thunderstorms ongoing right now out ahead of this front. Got a high pressure system out here. And so let's advance this forward into early next week. This goes out to Tuesday right now. This is Tuesday. That front slides south. The low starts to kind of shear out. Got a nice high pressure system behind this. Cooler and drier air for much of the United States now. So that's going to shut off activity for much of next week. As you can tell here, it just does not do much. We get a little bit of a push of moisture by next Friday, September 30th. And some low pressure systems, maybe some thunderstorms, some showers those days across the plains. High pressure system out east. But as we get towards early October, look at that thing brewing. That is that eastern wave out in the eastern Atlantic near the African shore that's tracking out into the Gulf. Now the models have this thing moving into Florida. So there it goes, boom, right into Florida. And the past couple of runs have actually tracked this thing into the Gulf. So it's it's worth watching, and it already exists out there, so it's definitely worth watching. So this has it going out into Florida and kind of quickly weakening. The last model run had it probably even stronger and out into Texas. So we're going to have to watch this closely. Again, it's still pretty far out. I've noticed that past about 240 hours, the GFS starts to get a little wacky. So a little trick that we can do is we can take this wave that we just looked at and we can track it back, okay? Or we can track it out or track it back. Yeah, let's do that. Try to take this out here. Here's our hurricane right here out in Florida. This is October 8th at 7 p.m. So here it is at Florida, okay? Let's track it backwards now, and we can watch where it goes, and we can actually see if this is actually that wave we were looking at. So here's our hurricane. It's kind of in this area right here. It's tracking it back. This is September 28th now. It's out in the middle of the Atlantic. This is the African shore out here. Okay, this is September 25th, so this is actually tomorrow, and you can see it's right over here. And currently, from when the satellite measurements were taken, it's right over here, so it is that wave. It's right kind of in this area, so that tracks it out kind of in this area, and then it loops up and hits Florida. So this thing is definitely worth watching. So this is kind of something we can look at. And most of these model runs for when the hurricane is near the shore, they actually do show a disturbance, at least something, like a tropical storm or a depression of sorts. This, you got a hurricane, probably a hurricane there, probably one there, one way up there. And you can see the timing is a little bit different. The location's a little bit different, like way up here into Canada on one, and then the other one's way in Mexico. So obviously it's going to vary a lot, and this is also saying the model's not very confident yet. It's confident in some type of system coming on because many of these members, these ensemble members, have some type of system, but it's not confident exactly where that's going to happen or the strength. But it's definitely showing signs of something happening and should be watched here. Alrighty, so what the heck is an ensemble? Well, these are essentially the computer models, so we can take the GFS, and what it is they change the initial conditions or change the kind of the equations ever so slightly. Okay, so say you got your GFS model run at like 12 p.m., wherever the heck that is when it runs. Okay, so let's say one runs at 12 p.m. What they'll do is they'll run multiple runs of that same GFS, but they'll maybe change the temperatures up. Maybe on one run, all of the temperatures or some of the temperatures 1 degree warmer. Maybe on the other one, it's like 2 degrees cooler. Maybe the other one, they change the equations up a little bit. And so you get all these different runs of the same run, okay, but they just change a little bit of the conditions. And so that it forms an ensemble. So you can imagine a bunch of strings or a bunch of like musicians playing an ensemble. So that's basically what it means. Just a bunch of different similar things playing the same song, but ever so different or ever so slightly different. So why they do this? Well, because over time, 1 degree difference, in a certain location or a few different locations, it can have a huge impact over time, okay? Or sometimes it might have a very little impact. It might not do much at all, okay? And this is known as the chaos theory. Wow, okay, if I can even spell that right. Try that again. I think that's right. So we got the chaos theory, the good old chaos theory. And that basically states, hey, if a butterfly is going to flap its wings in Colorado, there might be a tornado in New Zealand 2 weeks from now. Okay, so little tiny things can affect things, a lot in the big run, and maybe sometimes they don't. So it's very unpredictable and stuff. So that's why they run these ensembles, just to kind of get a general gauge of how, if the initial conditions change at all. Because, hey, we can't get every initial condition accurate 100%. you know, the stuff that goes into the models, we can't always get that 100% accurate. Sometimes there's station biases, and sometimes there's lots of gaps in the data. You know, when you have station plots where people take the current measurements, there's lots of gaps in those data. You know, like from maybe Lincoln, Nebraska or something to Concordia, Kansas, there's a gap there. And so, you know, those aren't always going to be accurate, and there's stuff that's kind of missing. So they like to run different versions of the model to kind of see how confident is this model, how confident. And so we got 3 different websites that I use. There's actually more, but these are 3 I commonly use. And you can type them or whatever, take a picture of them and type them in your browser, bookmark them. They're pretty good. EWAL, Tropical Tidbits, and NOAA each offer some nice ensembles. And so I'm going to go over the NOAA one real quickly. This is actually a really cool tool to use. It's called the Spaghetti Charts, and I call this the Model MUI Checkpoint. Okay, so I'll go over that in a second. All right, guys, so this is a cool little tool I use to gauge the model's confidence or accuracy farther out. It's kind of used to gauge its sanity. And so I'm going to show you that real quick. This is mag.ncep.noaa.gov. And this is NOAA's suite of models. So we'll click on Model Guidance. We'll click on GEFS Spaghetti, or SPAG, Spaghetti Plots. And this is the ensemble of the GFS. And then we're going to click on probably NAMER, that's North America. We'll look at that first, then we'll look out in the tropics after that. We'll click on, let's go 500, 534, 576. That's showing the heights, the 500 millibar heights, out to the 576 height line. Okay, that's what it's going to show, is the 576 height line. So let's loop it real quick. And so what do we got here? These are something we call spaghetti plots. And this is where the MUI Checkpoint comes in, the thing I've developed, and that's called a Model Under the Influence Checkpoint. Okay, it's an MUI Checkpoint. Under the influence of the chaos theory, of course. So this just kind of shows how sane the model is. So we'll kind of stop every few days, and we'll see how sane is this model, how accurate is it around this time, how confident is it, essentially. And so when these little spaghetti plots, well, first off, each of these spaghetti plots stands for a different ensemble or a different run of the GFS. And all of these together form the ensemble we were talking about. Okay, so that all forms an ensemble. These are each a little different change up in the initial conditions or physics of the GFS. And so you can see if you change it up, all of these little spaghetti lines, spaghetti noodle lines, whatever you want to call them, when they're close together like that, that means the model is pretty confident, okay? Or it's pretty confident that if you change the weather much, it's still going to look pretty much the same. And this examines kind of the 500 heights, 500 millibar heights. So this is like the mid-level jet right now. So that's kind of where it has it right now. So let's advance it forward a couple of days and see what happens. We'll have one of our first MUI checkpoints. Okay, so let's go 78 hours in advance. And this is for Tuesday. As you can tell, it starts to break apart a little bit. All these little runs start to break apart. All the noodles or spaghettis, whatever you want to call them. And that means the model's beginning to lose confidence. You can see it's close together in this area, so it remains confident that the 500 jet will kind of actually be in that area. But you can see it's a little bit less confident out here. It could be as far north as Canada. It could be closer to the Atlantic Ocean, the 574 height line or whatever, the 500 lines. Out here, it's actually pretty relatively unconfident. Okay, there's kind of spread apart, and it's a kind of a mess out there. So you can see as we go into the future, the chaos theory really takes hold. Things kind of start to get a little out of control here. We'll go a few more days in advance. Let's go out to 164. And look at that. Really, once we get out to here of 164, 162, I mean, it really starts to lose confidence. You got stuff flying everywhere. Really, the only general area is maybe kind of right here-ish. You can kind of see that. Generally speaking, you're dealing with only a couple of 100 miles of difference. Out here, it's just a complete mess. So you can kind of tell that different areas are the models have a little bit more confidence in, and some areas it doesn't. We'll go out into the future even more. Hey, look, that's our tropical disturbance down here. Do you see that? So it generally has, hey, it's going to probably have a tropical disturbance somewhere in that area right there. And so that's kind of where you get those cones you can draw with the tropical storms. I bet the cone kind of looks like that right now. Well, let's see what happens here. Of course, this is examining the mid-level jet. We'll examine something lower in a second here. But yeah, that's kind of what it looks like. It just goes everywhere. But it does have some type of low pressure system. A lot of those model members have some type of low pressure system moving in to the Atlantic and Gulf regions. So, but yeah, you can just kind of see how it gets so chaotic so far out, especially around 240 hours out. It just becomes a mess. And so take it with a grain of salt. Alrighty, and to wrap up our little tutorial here, we're going to take a look at the Atlantic Ocean and examine that hurricane and tropical systems. And we're going to go ahead and click on Model Guidance right here. And we're going to click on Atlantic right here. And then we're going to go back to that GEFS spaghetti plots right there. Okay. And so this is showing all of the pressure area, the heights we're going to examine, the pressure areas. We were originally looking at the 500 millibars, the kind of the mid-level jet stream area. Now we're going to take a look at the something closer to the surface, and this stands for mean sea level pressure, MSLP. And these little numbers right here examine the strength of the pressure, like the isobars. This one's 1,000. 1040, this one's 1004, this one's 984, and this one's 996. And there's other ones out there. So this will take that line, that isobar, and plot it on that map. It'll take the different member runs of that ensemble, all the different initial conditions that changed, and it'll show kind of where that isobar is located, okay? And so you can kind of get creative with this. If you're examining a hurricane or a tropical storm, you're probably going to want to choose a stronger isobar, like something like 984. So if only a couple of 984 bubbles show up, that probably means that there's not a lot of confidence that there's going to be a storm system that strong. However, if there's a bunch of them that show up, that means, hey, maybe there will be a storm system that's strong. So this kind of you can kind of gauge the intensity, the confidence in something being strong or weak, just based off clicking on these different isobars. Okay, so let's go ahead and just do 996, something in between here, and we'll click loop. Okay, and so here's our Atlantic right now. Let's go a couple blips into the future here real fast. Here's Carl out here. Okay, so obviously Carl is a tropical storm. Obviously that's going to show up with the 996 isobar. So this is you can just see one right here. That's where one model run has the 996 millibar isobar 30 hours into the future. Okay, you can see all the member runs out here, okay, of our ensemble. You can see a bunch of other ones in the same area. So all of them are kind of in this bubble right here. So there's a lot of confidence Carl will be in that little bubble right there. Okay, so if only like one or two were showing a bubble out here, it would say, hey, Carl's probably not going to be a 996 millibar storm. It's probably not going to be that strong. Okay? If there's a bunch of them, there's a lot more confidence that it's going to be strong. So let's advance that a little bit into the future. It begins to kind of become more not so confident, but it's still kind of generally in this area. But you can see the size changes, probably the intensity. Some of them probably disappear. You know, the shape changes. It's kind of wobbly now. And so you can kind of gauge a lot of different things from using these spaghetti plots in terms of model confidence. You can gauge the intensity, the size, the location, the speed, how fast it's moving. Some are up here, some are down here. You can gauge a lot of different things that way, and you can just gauge how many members are showing it, how many aren't. And so that's why I like to stop every few hours or every few days and do a model under the influence checkpoint, okay, an MUI checkpoint. So how, drunk is this model? Right now, it's beginning to kind of get tipsy. Carl's a little bit tipsy out there. Okay, so just realized what I drew there. So let's just advance this forward, shall we? And look what happens here. You can actually see that it was kind of not so confident. Now it's beginning to get confident again. Sometimes some features the models will handle better than other features. So you'll notice that as well. It's confidence that there's going to be a 996 broad area of lower pressure right there. You see that? Look at that. It even gets even more confident there. And then there it starts to kind of break away again. Now notice something interesting. You know the little wave we were examining out here? Now why isn't it showing up on this chart? Well, the wave isn't quite weak enough yet. Isn't quite strong enough yet to be a 996 millibar low. When it is, it will appear on the map, and it's about to happen right out here, so watch for that. Okay, we'll examine the future even more. Boom, right here, okay? There you go. You got like 3 different members, maybe that's 4, showing a little tiny, very tiny 996 millibar low. That happens Wednesday, September 28th at 18Z, so in a couple of days here, a few days, whatever. So we got 4 different runs, wherever they are. I'm not going to look at all the colors, but 4 different runs that show this. So based off that, still most of the runs don't show that. So I can say, hey, maybe there'll be a little disturbance here, but probably not a 996 yet. Even though those runs are showing up, most of the ensemble members aren't showing it yet. But it's always fun to just kind of watch that. But as we go into the future, hey, look, more start to pop up. More of these members get involved with the system and say, hey, I think there's going to be a system. We'll go into the future a little bit. And you can see that there's generally a lot of confidence that this tropical system is going to be right in that area, right there. But you'll notice that as we go into the future, we'll do another model under the influence checkpoint, that it begins to get tipsy with this system. It begins to, the cone, okay, you can make a cone. It begins to push these bubbles kind of all over the place. And that's how they make those little hurricane cones, the NHC and other data sources. They obviously use other models and their own analysis, but we're just going to keep it simple and use the GFS here. So let's advance it forward and let's make a cone when it does advance forward here. So we're going to push it forward. See how those diverge? They spread apart. And you'll notice that some are farther north, some are farther south, some are over here, some are over here. There's a little bit more confidence in this area. And you'll notice they're different sizes now. So there's different sizes, probably intensities. Some of these probably have disappeared. Maybe some have popped up. Maybe have disappeared and popped up again. So maybe it's pulsated. And you can kind of look for that. Different sizes, locations, intensities, speeds. Like this one's faster than maybe these over here. And you can kind of see that evolving. But you also notice that more variations mean less confidence. It was over here, remember? Like it was around like early October, late September. Now it's October 4th. So what I would do is if I was a forecaster, if I was examining the tropical storm or system or whatever it was out here, and I saw this, I'd have to make a cone to account for all of these bubbles, okay? If this is what I saw in the future, I'd make a cone like that. And obviously that's just absolutely ridiculous looking. Okay, that's a huge, freaking cone. So that means it's fairly unconfident, or not so confident. We'll progress into the future, and now it just becomes a mess. Another model under the influence checkpoint, and it says, hey, this model is probably wasted right now. I mean, there's a little bit of clarity right there. Okay, and actually that's what the GFS had. It had that tropical storm or hurricane tracking into Florida, kind of like that. So that looks about right. But look at this. You got a storm all the way out here. I mean, you got a fish storm. It doesn't even hit the United States. Granted, that's only one of them. But, I mean, when it's showing that, when you got some out here, when you got some out here, that's a pretty darn big range. Now, I would say that's an outlier. Okay, that's probably not going to happen. It's probably going to kind of be where they're all bunched up. Okay, but it still shows that it's not very confident. As you go into the future, this is towards October 8th, it just becomes a big old mess. So let's go back real fast, and I'm going to stop kind of where I think maybe there's a lot of confidence, and it happens right around the 240 hour mark. That tends to be the case, so you can kind of see there's still quite a bit of confidence here, but once we get past that 240 hour mark, man, it just becomes a mess. Things go crazy. And I've noticed that with a lot of different features, with a lot of different, not just hurricanes, just with a lot of things. Right around 240 is, the model begins to develop biases. And heck, even with that cold air outbreak that it was forecasting, that actually is starting to kind of go away a little bit, if you watched the last video. But yeah, the models start to kind of develop issues around 240, I've noticed on the GFS. So that's kind of a brief overview on how to use Ensembles, the spaghetti charts, and the MUI Checkpoint little method that I've developed. And so hopefully you enjoy today's tutorial and State of the Weather address episode. If you want more of these tutorials, and if you want more forecasts, and you want to further your weather forecasting skills, go ahead and subscribe below, or wherever that button is. I think it's right over here somewhere. Go ahead and subscribe, and I'll continue to launch more of these videos. And also, if you want exclusive content to even further your weather forecasting skills and want more weather forecasting tutorials and forecasts, go ahead and sign up to our email newsletter below in the links. I've posted it somewhere down there. Go ahead and sign up, and I'll release some more exclusive content for email newsletter members. And I hope you enjoyed today's video, and I'll see you soon.